NET-213, Cisco networking. This is Wednesday, week 11. We went over the data link assessment. We worked on some lab items, and then we started the physical layer. We reviewed briefly the layers. We didn't talk about them all. Then we talked a little bit about hexadecimal numbers. So we listed those. And we looked at that while we were going over the assessment for the data link layer. Then we worked on the lab. What we did, we adjusted the lab. We put everybody on a particular network on the switch. And the network the students chose was this one. We created a default gateway in the router. We created an IP address in the router. We connected up the items, and then in the router we did DHCP. Okay? So we did DHCP in the router so that all of the devices on the network received an IP. And we excluded the IPs 1 through 10, so everybody down here on the network was getting 192.168.14.11 on up. Seemed to work. They got a default gateway. We configured this link between the two routers. And so we tested, we had conductivity between the two routers. Called this one router 1. And then we called this one the ISP, and then we put a loop back in the ISP, and we made it 210, 10, 10, 10 to represent just some address out on the internet. Alright. Students checked, DHCP worked, they were able to ping 192.168.14.1, their default gateway. Then they also were able to ping 192.168.1.2. So inside this router they were able to ping. Now, they couldn't ping the ISP, 192.168.1.1. And they figured out quickly the pings were getting up there, but the ISP had no idea of where to send them back to. It did not know where this 14 network was. So we put in the ISP a static route pointing back at the network. So it's a static route pointed down here, so then the students then could ping the ISP. Then our next step was, can we get out to this simulated internet? And when they tried to ping that, they couldn't. They couldn't ping 210, 10, 10, 10. Okay? And the reason was, this router did not know where that was at. So it was dropping the packets. And the students again figured out this router needed a default gateway out. So we configured a default gateway in router 1, and as soon as we did that, we were able to ping the 210, 10, 10, 10. And then to finish up the testing, we had the students open a web browser and see if they could open up a web page for 210, 10, 10, 10. And we had the HTTP server on in this router, so that router responded with the web page. So our conductivity here was complete. Now we're going to add NAT to a similar situation here in the near future. And what did that prove? The pinging proves that we can get through at least layer 4, but accessing that web page meant we were getting through all the layers, all the way up to 7, because that browser has to come in through layer 7 in order to function. Then we were able to show that. Alright. Next thing we did was we introduced some things for the physical layer. We talked about the physical layer, where we're actually taking the frame right? We have transport layer, we got a segment. Network layer, we create a packet. And then at the data link layer, we create this frame. Now we have to take that frame and put it onto the physical medium and configure that so that it can be transported between the devices. Using that media access control, the frame should be set up correctly. So we have some standards for the physical layer. We got signals, connections, and cables. How are we going to signal it, how are we going to make the connections, and what kind of cables we're going to use. And we actually had some fiber optic cables out and so forth. I'll try to show those on Friday again. 3 major functions. Making sure the physical components connect. Then data encoding. We need to take a stream of bits and put them into a predefined code based on some standard. And then we got to figure out the signal. How are we going to either electrical, optical, or wirelessly to represent the ones and zeros? And I briefly showed a couple ideas on how we take signals and make them different. We can change the amplitude, and that's called amplitude modulation. We can change the frequency, which is called frequency modulation. We can phase shift it, and all of that is also dependent on the time. So we talk about bit time and so forth, and then we'll get into things like for voltage, what the voltage is, or this transition between voltages, which would be Manchester coding and so forth. How we represent the signal. So we just barely got the physical layer introduced. The students then took the pre-assessment for the physical layer. And that's it.